Good afternoon, and this is a walkthrough of session 1 for direct variation for at-home learning April 20th through 21st. This is on direct variation. We have already done direct variation. We are revisiting it and getting a little bit more information. So, direct variation, if you'll remember, is a special type of proportional relationship that can be written in the form of y equals kx, where k is called the constant of variation. In this lesson, you will be given a table. You'll have to decide whether it is a direct variation. And then from a table that is a direct variation, you'll need to come up with an equation. Some characteristics of a direct variation: y over x is the same throughout. So what you're going to do is for every data point in the table, you are going to simplify y over x, and if it is the same, then it is a direct variation. If it is not the same, it is not a direct variation. Direct variation is a special type of proportional relationship that can be written in the form of y equals kx, where k is called the constant of variation. Once you do this y over x and you simplify it, that is actually your k. Varies directly means that when x increases, y increases by the same factor. In other words, y and x always have the same ratio, which is k, where k is the constant of variation. If you remember the poster by the clock where you guys always looked at it and you're like, oh, I can't do it. It's y equals x. Yeah. Y over x equals y over x is the equation that you should write every time you see the word varies directly. Direct variations, the synonyms are directly proportional, proportional, and varies directly. So last couple of units you were doing the is it proportional? Now these are going to go a step further. Properties of a graph that has a direct variation: y equals kx. Notice it doesn't have a y-intercept. Line passes through the origin, which means that's a 0 out here as a y-intercept. Y-intercept of 0, 0, and the slope of the line is k. If you have a table like that and it asks, is it a direct variation? Is it a direct variation? What you are going to do is you're going to look at the table and take every data point. So this data point, and you're going to go 3 over 12, and that is 1/4 simplified. Then you're going to take 5 over 20, and you're going to simplify that to 1/4. Then you're going to take the next data point and do y over x, which is 7 over 28 equals 1/4. And then you're going to take every single data point, the entire table, because sometimes they'll have a lot of them do it, but just one won't, which means a no. That's 1 over 4x. And so 1/4, 1/4, 1/4, 1/4. Is this a direct variation? Absolutely yes. And then the equation would be y equals 1/4 x. And that is your equation if it asks for an equation. Sometimes you're going to have tables that are horizontal. You know that the best way is to put them vertical. So you go 2, 4, 6, 8, 10, 6, 12, 24, 48, 96. You're going to just go through every single one of them and go 6 divided by 2, which is y and x, and that's 3. 12 divided by 4 is 3. 24 divided by 6 is 4. I got somebody who doesn't match. This guy and this guy are 3. This guy is 4. This is not direct variation. So if it variation can't spell today. Can't spell any day. If it asks you for the equation, you're going to say no, it's not a direct. It does not vary directly. Okay, here we go. If y varies directly as x and y is 42 and x is 12, which of the following represents the situation remember, we're always looking for y over x. So it says y is 42. I get x is 12. I know that there is a 6, so that is 7 times 6 is 42, and 2 times 6 is 12. These factor out. This is my constant of variation, so my equation would be y equals 7 over 2x. This is what it's looking for. Here it says if y varies directly as x and x equals 9 when y equals 15, find y when x equals 33. Remember, it's always y equal y over x equals y over x, and you plug things in as you see them. So when y is 15, x is 9, and you set it to equal, I'm finding y, so I put a y up here, and x is 33. And then you solve for y. Since this is a divide sign, I'm going to multiply both sides by 33. And then because this is a divide sign, I'm going to multiply both sides by 9. And what happens is when I do that, that 9 and that 9 factor out, that 9 and that 9 factor out. So you have 33 times 15 equals 9y. Then you have 495 equals 9y. Divide both sides by 9. And you get y equals 55. I kind of do these backwards. I always find the value first. So y equals 55. Okay. Now I take any of the ratios. I either take this one right here or this one right here, because I now know that it's 55 over 33. I'm going to take the 15 over 9, and I'm going to take 15 over 9, and I'm going to simplify it, and I'm taking out a 3 of the 15 and taking out a 3 of the 9, so that is 5/3, which is the constant of variation. If I did it with the other one, it's 55 over 33. Both of them are divisible by 11, which would still give me 5/3. So my equation would be y equals 5/3 x. Next problem, if y varies directly as x and y equals 26 when x equals 2, find y when x equals 5. Again, my equation, y over x, should start way higher than that because I need some room. So I'm going to go up here. Y over x equals y over x. Here is one of them. So 26 over 2 equals y over 5. Again, I'm going to multiply both sides by 5 to get rid of the 5 in the denominator there. I'm going to multiply that side by 2 and that side by 2. When that happens, that 2 goes away with that 2, and that 5 goes away with that 5. And then I do my multiplication. 5 times 26 is 130 equals 2y. I divide both sides by 2. Y equals 65. What is the value of y? Y equals 65. Okay, then again, I go up and I take and I find my constant. Here's one of my constants. Oops, didn't do it in that color last time. Here's one of my constants. Here's one of my constants. If I do here, I do 26 over 2, which is 13 when simplified. If I do 65 divided by 5, that is 13 if I simplify, so that is y equals 13x. This is a review of a concept we have covered in class. It is getting you better at direct variation. If you have any questions after watching this video prior to you doing your assignment, please look at the tutor times on the schedule and attend one of the tutor sessions. Thank you.